Hi, I'm Miss Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on finding zeros of polynomials. The Massachusetts curriculum frameworks for mathematics are specifically tied to this lesson. A-APR, Arithmetic with Polynomials and Rational Expressions, specifically number 1A and number 3. Let's take a look at today's lesson objectives. To divide polynomials using polynomial long division and synthetic division. To use polynomial long division and synthetic division to find zeros when given a polynomial in standard form. To determine all the key features of a polynomial in its graph when given a factor of the polynomial. And to determine all the key features of a polynomial in its graph when given a zero of the polynomial. Let's take a look at our first problem. Determine if 3x plus 1 is a factor of f of x equals 3x cubed minus 5x squared plus 10x minus 3 using polynomial long division. So let's take a minute and review basic long division with integers. So if I think about how many times 5 goes into 132, I want to think about this long division problem first. And that's going to help me transfer my thought process when I'm doing polynomial long division. So I'd start and say, how many times does 5 go into 1? It doesn't. So 0 times 5 is 0, and I subtract and I get 1. I bring down the 3. How many times does 5 go into 13 without going over? 2. 5 times 2 is 10. I'm going to subtract these two values and get 3. I'm going to bring down my 2. 5 goes into 32. How many times without going over? 6. 6 times 5 is 30. 32 minus 30 is going to give me 2. So my answer would be 26, remainder 2. And again, I can think about this also as 26 plus 2 over 5. So this process and this idea is what I'm going to use when I'm taking 3x plus 1 and determining if it's a factor. I'm going to do that by using polynomial long division, and we're going to see why that is in a second. So I'm going to set up my problem. And I'm going to start to work on this. So I'm going to say to myself, 3x. How many times does 3x go into 3x cubed without going over? It goes in x squared times. So now I'm going to multiply this back. X squared times 3x is going to give me 3x cubed. X squared times 1 is x squared. And again, I'm going to subtract, and I got to make sure I subtract both of those values. 3x cubed minus 3x cubed is going to give me a 0x cubed. I can write that or I don't have to. Negative 5x squared minus x squared is going to give me negative 6x squared. I'm going to now bring down my 10x. And I'm going to illustrate the same process. And I like to circle this so I can keep it all organized. 3x goes into negative 6x squared, negative 2x times. And I multiply it back. Negative 2x times 3x is negative 6x squared. Negative 2x times 1 is negative 2x. And again, I'm going to subtract. Be very careful with your negatives. And it's useful to put this into parentheses if necessary. This is going to give me a value of 0. 10x minus negative 2x is going to give me a 12x. I'm going to bring down my minus 3. And again, I have one last step here. I'm thinking about how many times 3x goes into 12x. And that's going to be 4. 4 times 3x is 12x. 4 times 1 is 4. And again, I'm going to subtract. This is going to cancel out. Negative 3 minus 4 is going to give me negative 7. So my final answer is going to be x squared minus 2x plus 4, remainder of 7, which I can write as So our final answer is going to be x squared minus 2x plus 4 minus 7 over 3x plus 1. So let's get back to what they're asking us. Determine if 3x plus 1 is a factor of that polynomial using polynomial long division. So this process is our idea of polynomial long division. And what we're trying to see is if we get a remainder of 0. If we get a remainder of 0, then this, what we divided this polynomial into, is going to be a factor. So since we get a remainder of -7, 3x plus 1 is not a factor. Let's take a look at our next type of problem. So for the previous problem, we worked out polynomial long division. For this problem, we're going to use synthetic division to determine if x plus 3 is a factor. If x plus 3 is a factor of the given polynomial, what is that going to mean that the root is for this? So if I think about this and I'm trying to figure out what root connects to this factor, it's going to be -3. I don't know this yet. I'm trying to figure out if x plus 3 is a factor and -3 is a root. In order to do this, I need to use synthetic division. So I'm going to set it up and talk you through the setup. So I'm going to take my -3 and I'm going to kind of isolate it up here. And I'm going to look at the given polynomial and I check and I say, am I going from highest degree to lowest degree without skipping any terms? So I go from a cubic to a quadratic to a linear to a constant, and I've accounted for everything going from highest power to lowest power. So I'm going to write the coefficients that correspond to each of those here. My next step is going to be to bring down the first value, which is a 1, and from there, everything below the line gets multiplied by the root or the number that's isolated over here. So 1 times -3 is -3. I'm going to add down, so 4 minus 3 or 4 plus -3 is going to give me 1. 1 times -3 is -3. 1 plus -3 is going to give me -2. -2 times -3 is going to give me +6. -6 plus 6 is going to give me a 0. So what I make of this is I need to now write this as a polynomial. So I'm going to go 1 degree less from the highest power. So we start with a cubic. So my result is going to be a quadratic. And each of these terms goes with the next power. So this is going to be 1x squared plus 1x minus 2, remainder 0. So this is my answer. And if I did polynomial long division, I would get the same result, x squared plus x minus 2, remainder 0. So now the question is x plus 3 a factor of f of x equals x cubed plus 4x squared plus x minus 6? And the reason it is a factor, yes it is a factor, is because our remainder is 0. So -3 is a root, and x plus 3 is a factor because we got remainder of 0. Let's take a look at our next problem. Identify all zeros given that -3 is a root of the given polynomial, then write the polynomial in factored form and sketch the graph. So we're starting to put all of this together. If they're telling us that -3 is in fact a root, we can use synthetic division and confirm this by getting a remainder of 0. So let's do out the synthetic division. 2, 1, -13, and 6. The coefficients in front of each of the terms of my polynomial. I'm going to bring down my 2. 2 times -3 is going to give me -6. 1 plus -6 is -5. -5 times -3 is going to give me 15. -13 plus 15 is going to give me 2. 2 times -3 is going to give me -6. And positive 6 plus -6 is 0. This now represents another polynomial, which we've broken this down. So we're going to go 1 degree less than the polynomial that they gave us. So f of x equals 2x squared minus 5x plus 2. And again, this signifies a remainder of 0. We don't have to write remainder of 0, but please know that. And again, if we're starting with a cubic, 1 degree less from a cubic is going to give us a quadratic. So we have confirmed that -3 is in fact a root of the polynomial because we got a remainder of 0. That's also going to mean that x plus 3 is going to be a factor of that polynomial. So now I've broken this down to a quadratic. We've done a lot of work with quadratics, and we should be able to either factor this, complete the square, or use the quadratic formula in order to find additional roots and factors. So my first step is always to try and factor. And if I can factor, then I've broken it down. If I can't factor, then I must either complete the square or use the quadratic formula. So I'm going to say to myself, okay, I know I'm going to have a 2x and an x. I know my signs are going to be minus, minus. And now I need to think about how I'm going to get a -5 as my b term. So I'm going to try and put a 2 here and a 1 here. So this is going to give me -4 minus 5. That is going to be how this quadratic factors. So I can bring down the fact that this was in fact a factor from earlier. So f of x is going to equal x plus 3 times 2x minus 1 times x minus 2. This is going to be factored form. And what else did they want? Identify all the zeros given that -3 is a root. So our zeros are going to be, we determined -3 is a 0 or a root. And now what we're going to do is we're going to take each of the 2 parentheses that we built using our quadratic and set them equal to 0 and solve. So if I take 2x minus 1, set it equal to 0 and solve, add 1 to both sides, divide by 2, I'm going to get a half. X minus 2, if I set it equal to 0 and solve, I'm going to get positive 2. So these are my zeros, or x-intercepts, or roots. All mean the same thing. And my last and final step is to sketch. So I have factored form, I have standard form, I have my zeros, I know that my y-intercept is going to be 6, and now I have to sketch this. And we're really taking this to the next level and putting it all together. So if I want to sketch this, I need to think about my end behavior. I have a cubic, so I know that my end behavior is going to fall on the left and rise on the right. I can start to map out my zeros at -3, 1/2, and 2. This is going to be my y-intercept, my c value from my standard form. So I can also map that out. And if I think about my zeros and the multiplicity from the last video, these all have a multiplicity of 1. So they're all going to cross the graph. So let's work on this. If we start from our far left side, we're going to come up, we're going to cross at -3, we're going to cross at 6, cross at 1/2, and cross at 2. Our end behavior is accounted for our leading coefficient of 2x cubed. And this is how we work out this problem. Let's take a look at another type of problem similar to the previous one. They're telling us that 2 is a root of the given polynomial. So again, we can use synthetic division to start to work this out. I'm going to double check, make sure none of my terms are skipped. So I have a 1, a -3, a -18, and a 40. I'm going to crank out synthetic division and hope that I do get a remainder of 0, which is going to confirm that 2 is a root. Bring down the 1. 1 times 2 is 2. I'm going to add down -3 plus 2 is going to give me -1. -1 times 2 is -2. -18 plus -2 is going to give me -20. -20 times 2 is going to give me -40. -40 plus positive 40 plus negative 40 is 0. So that's a good sign. I'm going to go 1 degree less from my highest power. We have a cubic, so this is going to be a quadratic. And again, we can write remainder 0. We don't have to. And this is going to be what we break this polynomial down to. So using synthetic division, this process is always going to happen. We've seen 2 cubics now, where we break it down and we get a quadratic. And now we can either factor it, we can use the quadratic formula, we can complete the square, and it's really our choice. It really just depends on the problem. So because we got a remainder of 0, that's going to mean that 2 is in fact a root, and that's going to mean x minus 2 is a factor. That's what that means. So now I want to try and factor this. And hopefully it will factor. So I'm going to have an x and an x, a plus and a minus. And I say to myself, what times what's 20? That hopefully will give me a negative 1 when I think about multiplying the 2 binomials together. So I'm going to try negative 5 and 4. So this is going to be x squared minus 4x, positive 4x minus 5x minus 20. So that is going to give me negative 1. So I can now bring this factor down that I got originally and get x minus 2 and say that my factored form is going to be x minus 2, x minus 5, and x plus 4. This is factored form, which I worked out. My zeros are going to come directly from each factor. I'm going to set each parenthesis equal to 0 and solve. So the zeros are going to be 2, 5, and negative 4. These are my x-intercepts or roots, however you want to think about them. Typically, when they are integers, you say x-intercepts, and if they are imaginary, which we could get imaginary zeros, you would say roots and zeros, and we will take a look at an example like that. So our last and final step is we do want to sketch this and get an idea of what it's going to look like. It's a cubic, so my end behavior, it's going to fall on the left, rise on the right. I'm going to map out my intercepts, which are negative 4, 2, and 5. It's going to cross at all of these because it has a odd multiplicity. 40 is going to be my y-intercept, which this again is a rough sketch. So we're just trying to account for our y-intercept, our x-intercepts, our end behavior, the general shape. So here we go. We're going to start down here. We're going to cross at negative 4, cross at 40, cross at 2, cross at 5. This is all the information in the key features when we're looking at 2 as a root in our given polynomial. Let's take a look at the next type of problem where they don't give us a 0 or a factor, and we still need to find the zeros and the factors using the given polynomial. So our polynomial is x to the 4th minus 7x cubed plus 6x squared. So a couple observations is that our linear term and our constant term are missing. It's going to be at the end of that plus 0x plus 0. That's going to mean that our y-intercept is 0. So I'm thinking maybe if our y-intercept is 0, then maybe one of the x-intercepts is 0. I could use synthetic division with 0 and see if this is going to work, or I could start to use some algebraic techniques. So if I start to use some algebraic techniques, I can see if I can remove a constant factor. My constant factor that I'm going to remove is x squared. So when I remove the constant factor and divide each term by x squared, I'm going to get x squared minus 7x plus 6. And you can think about this as like the reverse distributive property. So now, if we look at what's in the parentheses, we have a quadratic. And we have this x squared out in front. So now I want to factor what's in the parentheses, and we're going to start to build from there. So again, if this could not just factor, we would use the quadratic formula or complete the square. So I'm going to have x and x, minus and minus, factors of 6 that add up to -7. I'm probably going to have a 6 and a 1. So let's double check that. X squared minus 7x plus 6, that is how that factors. I almost think about this as being x plus 0 and x plus 0, but we want to be as sophisticated as possible, so I'm not going to write it like that. So this right here is my factored form. We didn't have to do synthetic division. We could have. So our zeros, we want to think about our x-intercepts, our roots, our zeros. X squared, this is going to go with the factors x plus 0 and x plus 0. So I can think about that as being 0 and 0. X minus 0, x minus 1 equals 0. I could get a 1. X minus 6, set that equal to 0. I'll get a 6. And this is going to be my x-intercepts. So what are we missing? We have factored form, we have our intercepts, our x-intercepts, we have our standard form. Our y-intercept is going to be 0. So if I were to multiply these factors out, I would get this standard form and realize that 0, 0 is the y-intercept. The last thing that we have to do is sketch. So again, from the last video, at 0, it's going to touch the graph and bounce back up because it shows up twice. It has an even multiplicity. At 1 and 6, those zeros, it's going to cross the graph. So let's actually sketch this out. And we have our x and y axes. Let's label all the key points. We have 1 and 6. We have 0, 0 as the y-intercept. And a 0, x to the 4th. If I think about x to the 4th, this is like thinking about x to the even power. So it's going to be up and up. Rises on the left side, rises on the right side. So I'm going to start down here. I'm going to touch at 0, come back down, cross at 1, and cross at 6. So this is basically what my polynomial is going to look like. If you did not see to pull out an x squared and divide everything by that, you could have used synthetic division with 0 and built the same idea doing that. So that's something we're going to look at more during class tomorrow, but let's look at another example. Identify all zeros and factors given the polynomial x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4. So we have a 5th degree polynomial here, which is going to mean that when we work out synthetic division and break this down, it is definitely going to take more steps and more thinking to build it. So when I look at my y-intercept here, 4, this is how I'm going to start to think about what to use when I try synthetic division. And that's going to be my process. I'm going to try a bunch of synthetic division problems and see when I'm going to get a remainder of 0. When I have a remainder of 0, that's going to help me break it down because that means I have a factor and a root. So if I know that 4 is my y-intercept, I want to consider the factors of 4. Plus and minus 1, plus and minus 2, and plus and minus 4. I can try all 6 of these options in synthetic division in order to start to break it down. So it doesn't really matter which one you start with, you just have to try one. You may be wondering to yourself, when can I use synthetic division and when can I use polynomial long division? And there is a method and a reason why. So when I can try synthetic division is going to mean I have something like this. A factor that's raised to the first power and has a coefficient of 1. If I was trying something like this, I would not be able to necessarily use synthetic division because I have a coefficient of 2 in front of my highest degree. Another example of something I could not use synthetic division with is if I had something like this that I was trying to figure out if it would work. So it has to be something very simple where if you just set it equal to 0, that you can just get an integer, x equals -1, and that's the number that you're going to put inside the house, if you will. I'm going to try -1 and see if I get a remainder of 0 when I try synthetic division. And again, I'm going to put all the coefficients out in front here and work through my synthetic division. Bring down the 1. 1 times -1 is -1. I'm going to add down. -2 times -1 is going to give me 2. -3 plus 2 is going to give me -1. -1 times -1 is 1. I'm going to add down and get 4. 4 times -1 is going to give me -4. -4 plus -4 is going to give me -8. -8 times -1 is 8. 4 plus 8 is going to give me 12. So right off the bat, I can see that my last value is a 12. That's going to mean that -1 is not a root. So I can cross -1 off of my list. And this is the process. You have to try stuff. You have to use synthetic division. So -1 is gone. So now maybe I want to try +1 and see what that does. So I'm gonna edit this and put some values in here. So now let's try +1 and see if this gives us a remainder of 0. So it does. When we work out synthetic division using the process and methods we talked about, we do get a remainder of 0. That's going to mean that 1 is in fact a root. So I'm going to take my 5th degree polynomial and make this a 4th degree. So I'm going to have x to the 4th. I skip my cubic, minus 3x squared. I skip my linear. So each one of these values corresponds from highest degree to lowest degree. So I'm going to write this more simply so I can see what's going on. So I break this thing down to a 4th degree. So I want to think to myself, can I factor this, or should I keep trying synthetic division? You have two options. You can now look at this value and do the same method and think about what are the factors of -4 and use synthetic division to keep building. Or you can try and factor at any point. So I'm going to try and factor. If I think about this, this is in quadratic form, which means it goes from the 4th degree to the 2nd degree to the constant. So if I were to think about this as a quadratic, how would I factor it? I would have an x and an x. I would have a positive and a negative, and I would have a 4 and a 1. So this is how this would factor if this was a quadratic, and that's what we're used to. So now I say to you, what if we go back to what we had? How is this going to change? We're pretty much going to make this squared, x squared and x squared, and this will give us x to the 4th minus 3x squared minus 4. So I can bring down my x minus 1 factor that went with this root. And I'm almost done. I need to simplify these a little bit more because I need to get these all down to linear binomials. So I'm going to take f of x equals x minus 1 and see if I can now factor x squared minus 4. So I'm going to think about this as x plus 2 and x minus 2. X plus 2 and x minus 2. if I think about this one's not going to be as easy. So let's just start to think about what this means. X squared plus 1 equals 0. If I subtract 1 to both sides, I get x squared equals -1. If I'm trying to get x alone, I can take the square root of both sides. When I physically create a square root, I need to account for the positive and the negative branch. So x is going to equal plus or minus radical -1. What is radical -1? Radical -1 is I. So x is going to equal plus or minus I. So when I write my factors for this, I'm going to have x plus I and x minus I. And this is one of those moments where we're seeing that imaginary zero, that complex zero, and roots. So this right here is our factored form. X minus 1, x plus 2, x minus 2, x plus I, x minus I. This is factored form. Our zeros, or our roots, in this case I am definitely going to call them zeros because I have the i's. We're going to have 1, -2, +2, I, and -I. And the fundamental theorem of algebra is going to tell us that our highest degree is going to indicate how many zeros we're going to have. So notice we have 1, 2, 3, 4, 5, and we have a 5th degree polynomial. So our last step is to really sketch. So we have a -2, we have a 1, we have a 2. And you may be thinking, how do I account for the I and the -I? Well, we're going to see how that works in a second. Our y-intercept is 4. Our end behavior, it's going to fall on the left and rise on the right. And we are going to cross at all of those zeros. So we're going to come up, cross, cross, cross. This is going to be the sketch. And how do we account for I and -I? This is a sketch. So this is a rough estimate of what this graph is going to look like. Somewhere in here, or in here, these I and -I is accounted for. However, when you're doing your sketch, you can kind of just ignore what that would look like. And to get a better picture, we can use our graphing calculators to see how that's going to work. Let's take a look at the essential questions. When is polynomial long division and synthetic division useful? How do strategies for factoring quadratics come into play when finding zeros and factors of polynomials? Think about these questions tonight, and we'll discuss them more in detail when we start exploring these problems during class tomorrow. After watching today's video on finding zeros of polynomials, try these. Please try the following 5 problems and come in with questions tomorrow. Thanks for joining me in Core Concepts in Algebra 2. See you next time.